Good morning, ladies and gentlemen. This is Martin speaking. Today I'm going to tell you about how we are building Kubernetes as a service with GitOps and Cluster-API. So my presentation is divided into two parts. The first one is giving you the context. Who are we working for and actually what kind of scale we have. And the second one is the technical part. So first few words about myself. As I said, my name is Martin. I'm CEO of the company called DNation. I started to use Linux around 1996. Well, some of you might remember the old distributions which are not actually, do not exist anymore, like Linux Mandrake. That was the distribution I started with. Later I converted to Debian. I was solving problems like, some of you actually may remember that the support for special Slovak character wasn't great at the time. I was brave enough to install it on my girlfriend's computer, which didn't go very well. So I was playing a lot with hardware support, video card, audio card, floppy drives. That's where I got my knowledge about Linux. Today, all my family is running Linux, all my company is running Linux. We are strong open source supporters. So we are very happy we can be part of the open source community. As you can see, even my grandmother, who used to be 85, she passed away unfortunately. At the time, she might be the oldest Linux user in the world. And she was very happy with Ubuntu. About my company. My company is called DNation. The D in our name stands for two things: development, like software development, and DevOps. We are a sovereign cloud provider. Sovereign cloud means that everything is within the EU, and we are hosting our own operating systems, and the product we are developing called YAUG, OpenStack-based distribution on bare metal. So we fully control where the data is, and that's where we are running our own infrastructure and infrastructure of our customers. So there is no vendor lock-in, no dependency on hyperscalers. Actually, most of our companies are these days moving away from hyperscalers. Donald Trump is these days our best salesperson. We can see this mostly in Germany, France, United Arab Emirates, and surprisingly Africa. Our core technologies are OpenStack, YAUG, which you may not know. It's a distribution of OpenStack, Kubernetes, and OpenShift. About the project, well, we are part of Alaska Consortium, and as a part of this consortium, we want together with our partners like Uhrutech, the project for Horizon. Horizon is a new EU-based sovereign cloud provider, which is going to compete with well-established hyperscalers. It's fully open source, no vendor lock-in. Everything we produce there is AGPL v3 license, free as in freedom, so no hidden obstacles in that regard. There are going to be 46 data centers across Europe. Right now, you can see the map. 4 or 5 of them are built right now. Each of them has 1,500 nodes, which present certain challenges regarding scalability. As some of you may know, when you are adding more than 700 nodes to OpenStack cluster, we are using OpenStack as an underlying technology, there are scaling difficulties. There is a strong focus on sustainability. This is how the data centers which are built look like. So there is efficient water cooling. We are trying with them to use as much clean energy as we can. So it's really a new generation of data centers. We are turning into technical part of this presentation. So there are 4 projects called uView, uGarden, uStack, and uMetal, which are being developed right now. All of them, as I said, are already available as AGPL version 3. So first we are going to talk about these particular components. Well, when you have a bare metal, uMetal is the thing which is going to partition the disk via BMC interface, install operating system, and get it to the state when you can SSH to the machine. On top of that, there is Kubernetes on bare metal. That's what uMetal is doing. It has the capabilities of auto-provisioning new nodes. So you just plug in the new node into the network, and you tell it to boot the right image via PXE, and you will end up with another worker node or Ceph storage node or whatever you need. So you are at the point when you have Kubernetes on bare metal, and now you are going to deploy OpenStack. You are using uStack for that. uStack is basically the way how you can deploy OpenStack in an automated way. You can think about it as a tool which will take as an input Kubernetes namespace, and it will deploy in that namespace various deployment and stateful sets, each of them responsible for certain OpenStack functionality, like Keystone, Nova, and Cinder, and others. This gives you the ability to actually maintain OpenStack in using Kubernetes mechanisms like rolling update. One of the big disadvantages of OpenStack is it's a beast. It's very difficult to maintain, and if you have everything closed inside Kubernetes containers and deployments, it's much easier to go version up or version down via rolling update. So that's what uStack is doing. What is uGarden doing? Well, uGarden is taking as an input OpenStack distribution or kind, or there are also other platforms going to be supported, and it will deploy Kubernetes cluster on demand. One of the requirements is that we have to be able to define special flavors for end customers. Special flavors means that some of the end customers would like to use GPUs, so we need to create clusters on demand with associated GPUs which the workload can use. So that's what uGarden is doing, and on top of it is uView. uView is basically a user interface for end user, so he can see how much resources he is using, how much the bill is going to be, how much of his quota is still available, stuff like that. So this is how it looks like. At the bottom there is umetal, handling bare metal, installing Kubernetes on that. Then on top of it uStack, which deploys OpenStack in Kubernetes containers. Then there is uGarden, which is creating Kubernetes clusters, and on top of it there is uView. All of that is providing data to billing system, and all of that is actually does have its own API, so it is possible to automate it. Here you can see another view how uGarden is used. Well, from customer point of view, he's just using the Kubernetes. From operations point of view, they are maintaining Kubernetes, having looked to monitoring. We are using our DNation monitoring solution, which is already standard part of sovereign cloud stack. I'm going to talk about it later. So that's the one which is going to be used here as well. There is a cloud API, which is used for creating those clusters. And uGarden uses the underlying uStack infrastructure, provides data for billing, uses container registry, which is also part of the stack, and talks to authentication identity provider. So it is possible to connect this to third-party providers like, for example, Microsoft Azure directory, which is actually quite common use case, especially in intermediate phases when the customer is migrating from hyperscalers to on-premise solution, because Azure is directory ID is usually the last thing which remains there. So regarding uGarden Kubernetes as a service platform architecture, well, many of you probably already know this picture when there is a bootstrap cluster and then management cluster and workload clusters. The new thing here is platform management cluster. So how does it work, the whole thing? Well, at the beginning, usually on the local environment, which would be your notebook, you are using and bootstrapping what we call bootstrap cluster, which is basically kind Kubernetes in Docker. Once you have that, you can create from there using operators platform management cluster. That's the one which is going to be in charge of all the clusters, Kubernetes cluster for the whole cloud. So there is just one instance of that. From there is per customer management cluster, which is going to be deployed on his infrastructure. And from there, customer is using Cluster-API to face this management cluster and creating his own workloads on demand. So you can have actually multiple OpenStack domains, one per customer, or you can also think about it as a tenant, multiple clusters per, one cluster, management cluster per OpenStack tenant. How does it work technically? Well, we use GitOps approach everywhere we can. So operator updates Git or API is used to update Git repository. Then there is Flux, GitOps tool, which will transfer that into platform management cluster calls. That will transform the thing using Cluster-API to management clusters, and that will eventually spawn workload clusters for customers. So, what is the platform stack we are using here? There is a Cluster-API operator, which is the lifecycle of Cluster-API providers. There is Flux, we already talked about that. That's a GitOps approach. There is Cluster-API addon provider for Helm, which is basically packaging in Kubernetes. There is Kyverno, where we are using, which we are using as a policy, as a code component for Kubernetes. Then there is Kamaji, which is doing the shared Kubernetes control plane. We don't want actually to have, as you know, Kubernetes control plane has a footprint, especially when you are running in a redundant mode, three nodes per control plane. And that's something you don't want to have for each cluster. So we are using Kamaji to have just one shared control plane for multiple clusters. Hyperscalers are doing something similar. When you install or provision the Kubernetes cluster, usually you don't have access to control planes. You just have an access to worker plane. That's what we are using Kamaji for. Then there is Kubernetes external secret operator. That's for integration with external secret management systems. One of them is AWS Secret Manager. Then another quite known is HashiCorp Vault. These days, I believe HashiCorp has been sold to IBM, so IBM, HashiCorp Vault. So that's basically an injection of secrets from an external provider into your Kubernetes workload, usually in the way of providing environmental variables or any other common mechanism for exposing secrets to workload using Kubernetes. Then there is OpenStack Resource Controller. That's a declarative management of resources. And last but not least, there is a lot of custom Go code which goes between Kubernetes operators. From what I talked until now, it may look that this is mostly integration work. Well, that's actually not the case. Integration work is probably around 40% of the whole project. The remaining 60% is coding the new functionality. We are using Crossplane. Thanks for the nice presentation we had about Crossplane just before me. We are using it in production. It does work. We are using Crossplane to actually translate the calls between a particular, okay, to keep it simple, there are multiple providers for infrastructure. One of them is bare metal, that we talked about already. But then there are already existing customers running on grid scale. Now you need a way how to transfer these customers from grid scale to on-premise. That's one thing. And also you need a way how to have a stable API for creating Kubernetes cluster and other things on two very different platforms, one of them being gridscale, another being bare metal and OpenStack. That's what we are using Crossplane for. What else the custom Go operators are doing? Billing system, for example. There's a difficulty. Those of you who are using OpenStack might be aware that OpenStack is great when it comes to CLI and API interface and separation of tenants. Those are strong points, but it's quite weak when it comes to UI. You have the Horizon dashboard, which provides you the basic functionality. You can see what are your VMs, how much memory they use, and this kind of stuff. However, there is no way to create from the UI the Kubernetes cluster. There is no support for that. You can't see how much have you spent during the particular month. There is no estimation how much you are going to cost. There is no billing. There is a support for billing. Actually, it's called Celometer, which creates the data for billing, and there is Gnocchi, which is kind of like storing those data in a form which you can then query and get an aggregated information. Unfortunately, it doesn't scale. When you have hundreds of VMs, not even thousands, Gnocchi request just takes too long. So we have to re-implement that. That's what we are doing. How are we doing that? Well, we do like to reuse things which proved themselves to work in the test of time. One of such things is Kubernetes reconciliation mechanism. And we are just using that for when you are creating the new VM, there's an object, custom object on Kubernetes level. When you are creating the new storage, associating a hard drive storage with VM, there's a new object. All that has to be coded in Go language as a Kubernetes operator. And then once you have that, you can use the standard tools for monitoring like Prometheus, which will notify you when those objects did exist. And then once you have that, you can write on top of that a reasonable, scalable system which provides useful APIs for a provider to query that and to have an accurate information what was actually used. That's where the real complexity is, and that's where actually we spend most of the time. So this is not, I would say it's half and half. Half of that is DevOps, how to integrate those things and be sure they work flawlessly together. And the second half is to implement the logic, business logic and lifecycle logic of tenants, of this kind of stuff takes a lot of programming. Well, what are the supported infrastructures? Obviously, OpenStack, we talk about that. OpenStack does have an ability to run on a single node, like your notebook. It's called DevStack. However, it's not really very stable. For example, it doesn't support reboot. So we are using for local development and CI just Docker, which is much more mature solution than DevStack itself. The uGarden Kubernetes as a service is in no way dependent on OpenStack. It just uses the API, so there are multiple providers, and we are planning to add more because, as most of you might know, OpenStack is a great tool and great project. However, it's very complex. Eventually, down the road, we can imagine the new way how we are going to manage VMs, and that's gonna be probably something which is written in the more strict language than Python. OpenStack is written in Python, so you can actually catch things during the compilation time and not during write time in production and have long sleepless nights. So we are preparing in the way that probably in 5 to 7 years' time we're gonna use something else. We already know what it's gonna be, but the development of itself is gonna take a while because OpenStack is a result of the work of many companies, so it's not that easy to replace that. If you don't count VMware, which is not open source, then there are not really a lot of alternatives. There is OpenNebula, there is Proxmox, but Proxmox actually has a limitation to 32 nodes cluster, which doesn't scale. OpenNebula never really got the traction, so there is not strong enough community around that. Then there is Apache, I believe it's called Apache CloudStack. That kind of works, but again, community is not big enough, so we will have to probably develop something ourselves. This is the roadmap for 2025. So as you can see right now, we are working on minimal viable product, which means bootstrapping, management cluster, create and deletion, basic end-to-end test, observability. We are soon going to do become a restore integration with UView, which is also being developed as we talk now. And integration with billing, obviously the whole project, the billing is important part because we want to keep it. Yeah, the money flow has to come in. And then, long story short, there's a lot of work. It's planned for 3 years. However, it has to go to production in second half of this year. The first data center has to be active by that date, so we are pretty busy these days. Yesterday I had a talk about DNation monitoring. It's basically, for those of you who did not have a chance to attend the presentation, it's basically the custom Grafana views for specifically designed for Kubernetes and OpenStack and some more 20+ platforms. It's already the standard part of multiple projects as a standard monitoring platform. This is going to be the next one. So we are going to deliver it at scale. That's already developed. However, we never use it on more than few hundred nodes. So now there's going to be challenge how to do that on 1,500 nodes. We do believe it's going to work because we already are using as an underlying architecture Thanos, which is doing a great job regarding amount of data and downsampling, so it's gonna work. I actually mentioned multiple times sovereign cloud or sovereign cloud stack. I would like to know, just out of interest, how many of you ever heard the sovereign cloud words and whether you do know what does that mean? Okay, we have few hands. Yeah, the market seems to be moving, and now I'm in European market, more into the sovereign cloud infrastructure. Why that? As a Europe, we have incredible dependency on hyperscalers. You could see that from the amount when you're working with cloud, most people by that mean AWS, Azure, or Google. Now, isn't that kind of strange to store the data which are very sensitive, like government data, in systems of a government which doesn't seem to act very friendly to us recently? We've been pointing to that since 2018, and we were part of this Sovereign Cloud Stack initiative. And there are countries in Europe which do believe that their data should be stored in on-premise within the European Union. Those countries are Germany, France, Benelux. The rest of the Europe doesn't seem to care too much yet. Then outside of Europe, is before mentioned the United Arab Emirates. They are very strong believers into having their own sovereign infrastructure. And surprisingly, Africa. Why Africa? Well, there's a lot of investment from China, Russia, and there's basically nothing right now. So it's a good market because you don't have to persuade someone to migrate from hyperscaler. There is just nothing. So as we talk, we have two guys who are using our materials, training materials for sovereign cloud stack and delivering speeches and trainings in Kenya. Surprisingly, I was very surprised to learn that Nairobi, that's where they are right now, has very favorite climate. It's close to equator, so I was expecting something like 50 degrees and not working air conditioning. That's actually not the case. You can check it on weather application that during the night they have 16 degrees, during the day they have something between 24 to 27, which was surprising. I still have to check out how does that work. That's the city close to the equator that has such favorable weather conditions. Long story short, there's an interest in sovereign cloud. Sovereign cloud means that we are going to store and handle data in the way which is clear, which is secure. There is no question whether or not is someone misusing our data or having a look over our shoulders, or whether they can switch off the power when they don't like a particular country. Like you probably heard recently about Donald Trump threatening Greenland and Danish government. Well, they're also migrating right now out of Office 365. Then there is this French city, I forgot the name of, they migrated recently. Honestly, there are not many alternatives to Office 365 right now, but the partners in the ecosystem are working on that. So that's sovereign cloud stack. It's a standard, and there are multiple implementations of that standard. Before mentioned, YAUG is one of them, and that standard ensures operability between existing and future European clouds. So you can actually take the workload and migrate from one provider to another in a transparent way for an end customer. That's what sovereign cloud is about. We are hiring. It's a lot of work. As you can see, we have the roadmap for next 3 years. So this chunk of work is just too big for us and for the ecosystem. If you are interested into international projects, write to careers.dnation.cloud. There's a lot of DevOps challenges, a lot of Go code which needs to be developed. So if you are a software developer and you would like to see new challenges at scale, write to the email address. I would like to thank you for your attention. Don't hesitate to talk to me if you have any questions. We are very friendly folks. We strongly believe, as I said, in open source. We took a lot from open source community, and we are ready to return as much as we can free of charge. So if we have a knowledge or we can be helpful in any way in any of your adventures, feel free to contact me, and we are going to provide it free of charge because we received a lot free of charge. All my company is running on Linux. We are using open source wherever we can. We don't have the single Microsoft or similar instance. We are ready to return to community. Thank you very much for your attention, and now your questions, please.
Thank you. First question, where to find your software? You mentioned it is under open source license and it doesn't seem to be available on your company GitHub or anywhere else.
That's correct. It is available on GitLab, and from top of my head, I should probably put it into presentation, but as you know, these things are usually prepared very last moment, like on the train from Germany yesterday, actually the day before. So let me fix that. Okay, I don't have an internet connection, but I'm going to tell you. It's gitlab.com/uhurutech. Uhurutech. I'm wondering whether there's an easy way. Oh, maybe I can just. Yeah, here. This is the. Yeah. Why is it Uhurutech? That's one of the companies in consortium which is actually developing. Another is DNation. There are several others. So we had to decide who is going to host source code, and we decided for Uhuru because they have there are reasons for that. Okay. Next question, please.
Next question. You mentioned there is a lot of custom Go code, and who is actually managing and maintaining that, because with the speed of Kubernetes evolution, it is a lot of people, a lot of energy required to keep up with our current versions, with upgrading, to avoid the technical debt creation.
Yeah, that's actually a very good question. This is one of the things we discussed a lot internally. And again, it's probably best when you are solving the issue of backward compatibility, because that's the core of the question here. It's usually a good thing to have a look how others solve that. And in this particular case, we believe Kubernetes did, again, pretty good job. Google engineers know how to do their stuff. So obviously, we will have to do the versioning of APIs. We are going to be backward compatible as much as we can. And, well, still it's going to be a challenge, but this is not our first project. And we have to do it using common mechanisms, being versioning of APIs being one of them.
I think this is all. Let me check the Slido first. Yes, this is all. We have answered all the questions, and we have still 3 minutes to go. So thank you very much for being within a time frame.
Thank you very much for your attention, and enjoy the rest of your day. Thanks.